So today I thought I'd make a starter's guide to Marlin so that you understand how to load your board. Now there's multiple types of boards out there, being 8-bit or 32-bit boards. So I wanted to walk you through understanding the process and how they changed it in Marlin's firmware. So what I'm going to do right now is I'm going to bring you over to the Marlin website so you can see the actual configuration. So Marlin has a web page right here that's marlinfw.org. Now, as you can tell, there's actually a section for download over here, and the latest release is always what you want to work with, just so people understand. Where you see bug fixes down here, this actually means that they're working on changes to the actual firmware. So while it might be bleeding edge in that it's brand new, it may not be stable. So you want to focus on the latest release, which is mostly the most stable that you can work with. So as you can see here, the version is 2.0.9.3. So I'm going to walk you through the process real quick of downloading this. So if you click on the download button right here, it will then pull it to your computer. Now there's also configurations, as you can tell over here. So what I'm going to need to do is, first of all, show you how to extract this. Now there's several ways to do it. So I'm going to right click and I'm going to click on extract all. Then I'm going to click extract. And as you can see, it'll extract the open folder right here. So while that's going on, we're going to go back over to the Marlin webpage for a moment. And we're also going to check into configs. Now, I generally do not use the example configs due to the confusion that they can cause, but I'll show you how to actually pull these. So over here, if you want to grab the actual downloads for configurations, what you can do is click on the code button right here and then download the zip. So this might take a moment as well. Once that's complete, we can actually go back over to our folder, which is going to be right over here, and extract the actual config as well. And this one will be pretty quick. So we'll just click on that. And I'll show you what's contained therein. But keep in mind that this configuration file is probably based on configurations that they think you may have. So let's take a look around real quick. You can see that there's a configuration file with configs. Then you have example configs. So the most commonly used one would be the Creality. And then you can see the type of printer. So you have the Ender 3 right here, and then all the boards that work with something like Big Tree Tech. Then you have FISEC, and you also have the MKS Robin that's apparently in here now, as well as another brand. But as you can see, there's a lot of choices, but inside here it's very simplified. So if we were to pick, for instance, the SKR 1.4, you could see that there's a configuration file for configuration.h and configuration.advanced.h. You would copy these like so over to your regular downloads folder, which would be the extracted one right here, and you would paste them into this folder. Now, I'm working from a scratch build, so I'm not going to do it, but I will pull in other files because I want to show you other functionality. So a user gave me 2 of their config files, and I wanted to show you some additional functionality that you can add to VSCode with Platform IO. So I'm going to go into this folder and I'm actually going to paste these, and because they're not like names, we shouldn't have to worry about them. See how it's user.h and user.h for the ending of them? That shouldn't conflict with this. So I'm going to close out of here and I'm going to show you something about the board for a moment, but I'll bring up VSCode real quick to show you how to do this. If you click on this Explorer button right here, then the Open Folder button, then you go to your Downloads folder, Marlin 2.0, Marlin 2.0, then select Folder. this will open up the actual configuration for you. Now, as you can see, there's going to be a Marlin folder right here with two different configs. This is the ones that we placed in here, and the reason I showed you this is because there's a new functionality that a user pointed out to me for comparison. So to load it, you would just type compare, and you can find the actual one. In this case, I installed this, being compare folders, and that allows me to actually compare files. So if I click on this file, being the user.h, and then my regular config, and right click, I can then do a comparison in here for the selected files. And then you can see the differences as you scroll through the file to figure out what the configuration is that you wish to work with. So that's just a new functionality that I thought I'd point out that someone explained to me. So as you can see, there is a configuration.h right here, and it looks like it's for the Ender 5, but the actual configuration that we're working with is going to be generic. So in this case, what we're going to do to set this up is we need to set our motherboard environment. So to do that, you're going to have to go over to Source, then you're going to go to Core, then you're going to go to boards.h. Inside here, you need to find your board. So we're going to start with the simplest board, and I'm going to point that out to you right now on the desktop. So over on the desktop, you can see that there's the actual Octopus by Big Tree Tech here, and this is the Octopus Pro. Now over here is the MCU, which is the main processor for the board. This is important because if you don't know already, this will help you select your configuration. So if we go back over to the desktop of the computer, I'm going to search on Octopus by pressing Control F. And as you can see right here, we have the Octopus board that we're looking for. So we're going to right click and copy this. Then we're going to minimize the core folder and the source, go to our configuration.h, and we're going to paste it over the boards_ramps14EFB. So let me highlight this real quick. And there's our configuration. When we're working with a 32-bit board, there are some things that have been pointed out to me over time. Normally I put -1 here for the value, and that's the USB connection. But in some instances with other types of boards, there will be an issue that we run across where we need to actually have this be 0 so that they can use a display. In which case, you'll use the second one down here by hitting the Control / to remove the comment and communicate via USB with this one. But most of the time, you'll see me change this one up here. So for now, that's what I'm going to change. So up here, I'm going to change this to -1. And then for the basic actual compilation of this, we have to go to platformio.ini. And for those of you that have never installed this before, you're going to download the Visual Studios or VSCode, and you're going to install it following the executables for the install. But if you need Platform.io, you're going to click on Extensions. Inside here, you can actually type Platform.io, and you're looking for the IDE. Now, currently it's installed on my system, so I'm not going to worry about this. Now, there may be other versions of it, but currently we don't really care about this for this tutorial. But for now, that's how you find it and install it right here. So let's go back over here and get to the issue of actually setting up the environment to actually build. So here you can see that it says platformio.ini, and you can see that the default environment over here says Mega 2560. So our default environment is not that. That is for the ramps chipset, and I'll show you what the rationale for this is right now. So I'm going to grab a board for the MKS Gen L so that you can see what's going on and show you this. So I placed it over the ramps board, and as you can see, there's actually a chip right down in here. And if you zoom in on this, you'll understand what I'm talking about. So as you can see, it says ATmega 2560. That is the chip that we were just referring to over here. So that's the processor. So if I remove that board and show you the other one, we can figure out what that is. So as you can see over here now, it says STM32F446. It's a little bit smudged because the board is old, but that's how we're actually going to set up the build. So I'm going to go back over to the build now, and I have to find that. So the way that you do that is you go to the INI, and inside the INI folder, you'll see an STM32F. So we're looking for 4, which is this one. So now you're going to search on Octopus. So let's type that in. And as you can see, there's multiple processor types. Now, what has happened currently is that Big Tree Tech and other manufacturers have run low on chips. So this has changed the way that they actually make boards. They substitute in other processors. This is probably not the best example, but down here you can see that it says F429. That's the last 3 digits and the processor type. So F4429 is actually another processor. But in this case, we're using this one up here, which is STM32F446. So we're going to copy this environment, and then we're going to go back over to our folder down here for platformio.ini, and we're actually going to paste it over the processor for the ramps that was there. So that's our default environment. Now, I need to remind you that up here it says Mega 2560. That was a previous build when you downloaded. It is not currently present, so you're going to have to click on the clean button that is present when you load platformio.ini. So you'll click on that, and it'll clean this folder out. Now, to build it, what you're going to need to do is click on the checkbox down here, and by doing that, it will begin to build. Now, keep in mind that sometimes your build will fail on the first build. The reason for that is sometimes things build out of order. So in order to fix that, you're going to click on the checkbox a second time if it does fail. If it fails a third time, what that may mean is that something is wrong in your actual build and needs to be corrected. And you'll be able to see that down in here. So this was successful in this case. So for 32-bit boards, we actually have to load the actual build via a SD card. So I'm going to click over here. I'm going to then find our build, which in this case is firmware.bin. It may vary depending upon which board you are working with. For instance, if you're using a Nano type board by MKS, it may have a different name for the binary file, but it will say bin probably at the end. So you'll right click on this, and then you'll say reveal in File Explorer. Now I need to go back over and set up my actual configuration here. So what I need to do at this point is I need to grab an SD card so that we can actually load this. So I'm going to grab one that's somewhat large in size, hopefully. So I'm going to grab a 32-bit version. So this is where people have a lot of problems. Originally, I was under the impression that it only had to be 128 megabytes. So I'm going to show you this real quick. So I've set it up over here, and I'll show you what I'm talking about. Let me zoom out real quick. So down here we have an SD card. I'm using a 32 gigabit. I'm going to put it into a card reader. So in order to do this, I have to turn my head for a second. And I'm going to place it inside the actual drive. Then I'll place this inside the computer, if I can get it in here correctly. Give me a second. There we go. So you'll hear a beep. Now let's go back over to the computer. And on the computer, you can see there's a folder right here for the actual drive that just appeared. So sometimes you need to format that. You can do that as FAT32, but we can check the properties currently and see what they are. Right now it says FAT32, but there is the possibility that you'll want to format it as your own drive. So we'll go to Format so you can see it. And you can do it right here as well by clicking the Start button with a quick format. But seeing how we don't need to do that right now, we're just going to right click and we're going to send this to the actual drive. Now you can confirm it's there. Now if you have a successful load, what will occur is this will be all in capital letters and then it'll say .CUR. What that means is current, meaning that it was recently loaded. Now a lot of people say that the file type means something else, and I understand that, but in this case that's what it means. So I'm going to pop the drive out for a moment, and then I'm going to go over to the desktop again, and I'm going to place the drive in here. So there's some important things you need to know about the board. Let me move over here to do it. So as you can see, I just inserted it, and one of the things that we need to know is, does it require USB power? Some boards will require it, such as the MKS board actually goes through the USB, so you can actually do an upload. And the upload, what I mean is this. If you go over to VSCode, inside VSCode there's two buttons here. There's the build button, which I call compile, and then there's another build button, but this one's used for upload, which means go through the USB. But this one does not require a jumper setting, whereas some of the SKR 1.4, 1.3, and I believe the SKR version 2 require the jumper to be in the USB position when loading via USB power. In other cases, you can take the actual jumper and put it on direct power depending upon the configuration of the board, and insert the actual USB and load it via your PSU power. But let me show you how to do this real quick. So I have it set up. All I have to do now is connect the USB. Give me a second here to align it. Sorry, you're seeing the top of my head here. But let me plug it in here. And you'll see it flash for a second. And after you hear that ding, it means that your computer can now see it. So if we were to go over to the computer in a moment, what I'd need to show you to actually connect to this is the actual configuration for something like Pronterface. Now, Pronterface is kind of a dated tool now, but the reason that I want to show you this, it's a good way to troubleshoot. So let me bring this up for you. So over here, you can see that the COM port is already known, possibly, but there's other ones. So what I want to do to verify it, if I need to, is type device manager. And this will bring up the device manager, which then will allow you to check on your actual drive. So in this case, we have COM port 1, and then we have the STM Microelectronics virtual COM port, which is COM port 15. So by opening this before we plugged it in, or after we plugged it in, pardon me, we were able to actually see it with Pronterface. But this is a tool to troubleshoot mostly. You can print from it, but there are better tools like Cura. So I'm going to connect to see if it works. And as you can see, it is connected now. Now, the board that I'm using currently has no end stops connected. So I'm going to test it, and they should all say triggered or open. I'm not sure which, but you can do that by doing an M119, and this will allow you to see the status of your end stops. So as you can see right now, they all say triggered because there's nothing connected. And for those that are interested in actually understanding the sub-nature of how to set up your board, I do have multiple tutorial lists that I'll put in the description so you can pick the playlist that suits your configuration. Just keep in mind that Marlin is always changing, so some of them may be somewhat dated. And I also want to thank my patrons and the people on PayPal for helping make this possible. Without your help, I would not be able to make these tutorials. And everyone, take care, be safe, and please like and subscribe.